Hi everyone! Welcome to the second chemistry video from LearnIt by Pintar. My name is Giovanna and I am the chemistry teacher from LearnIt, and today we'll be discussing Medium 1 Elements, Compounds, and Mixtures. So this is actually the next level of the foundational 1 level that I have made in the previous video. So if you have not checked that out, you can go to LearnIt YouTube channel, and there is the video where I discussed about foundational 1 topic, which is states of matter. Okay, so today we'll be discussing, of course, by the topic name itself, it's going to be about elements, compounds, and mixtures. Next is about separation techniques, and lastly about chromatography. Now let's start off with elements, compounds, and mixtures. I'm going to start off with what is an element. Well, it is a substance made of atoms that all contain the same number of protons and cannot be split into anything simpler. So the key words here is that element is made of atoms that all contain the same number of protons right here, and they cannot be split into anything simpler. So an example of this, as you can see, I put a diagram of periodic table, and this is actually an example of an element. There are 118 elements found in the periodic table, and for example, copper, iron, magnesium, sodium, hydrogen, they're all part of elements. Next, I'm going to move on to compound. So what is a compound? It is a pure substance made of two or more elements chemically combined. So the key word here is that it is two or more elements, they are chemically combined together. And also take note that it cannot be separated into their elements. They cannot be separated into their elements by physical means. So an example of this is copper 2 sulfate, CuSO4, carbon dioxide, as well as table salt. And lastly, what is a mixture? So mixture is actually a combination of two or more substances that are not chemically combined. So if you can see the previous one, this is a pure substance, and in compound is that they are chemically combined, but in mixture is that they are not chemically combined. But from compound, they cannot be separated by physical means, but for mixture, they can be separated by physical methods or physical means. And what this means is that it can be separated through filtration, through evaporation, and etc. An example of this is sand and water, or oil and water, and there are many other examples of mixtures. So a tip from me to actually learn about elements, compounds, and mixtures is I think that besides learning what it means or the definitions of what elements, compounds, mixtures are, you also must be able to classify any given substance. So I want to do an example question just to help you classify what it means by elements, compounds, and mixtures. So the first question here is, how are elements different from compounds? There are four options. A is elements cannot be separated into similar substances while compounds cannot. B, elements have a fixed composition while compounds vary in composition. C, elements are made of only one type of atom, whereas compounds are made of different types of atoms. And D, elements can be found naturally while compounds are naturally occurring. So pause this video to answer the question, and when you already have the result, you can play the video again. Okay, so the answer is C. The elements are made of only one type of atom, whereas compounds are made of different types of atoms. So let's review from the options here. So for option A, it says that elements can be separated into simpler substances. Well, no, elements cannot be broken down to simpler substances, and compounds can be broken down, as mentioned here. It says that it can be separated or broken down into its constituent elements. Um, for B, elements have a fixed composition while compounds vary in composition. Well, no, because both have fixed composition, so B is also not the correct answer. C, yes, it is the correct answer because elements are made of only one type of atom, as you can see, because they have the same number of protons. However, it says here also compounds are made of different types of atoms. Well, yes, because they are made of two or more elements chemically combined. So they can be made of two different types of atoms. Okay. And lastly, the last option is D. It says elements can be found naturally while compounds are naturally occurring. Well, no, because both can be found naturally. So A, B, and D are incorrect, and C is the correct answer. Okay, moving on, we'll talk about pure substances. Now, what does this mean? Well, from the start itself, you can see that it says pure. What does pure mean? It's basically like natural or anything clean, and that's kind of how it is, what the definition of pure substance is. So it only consists of a single element or compound which contains no other substances at all. For example, you have pure water and it only consists of H2O and there's nothing else contained in it. However, if you take, for example, drinking water, that would be classified as a mixture and not a pure substances. Why? Because it contains H2O molecules and other additional substances like dissolved ions and chlorine, which makes it a drinking water. So that's what differentiates pure water and drinking water. Um, here it says pure substances melt and boil at specific and sharp temperatures. An example is, okay, I'm going to take pure water again. It has a boiling point of 100 degrees Celsius and a melting point of 0 degrees Celsius. And so it is very specific and it's sharp, and that's how pure water is going to melt or boil. But this is different if it's an impure substances. Well, it has a range of melting and boiling points. So generally, impure substances have lower melting points and higher boiling points than the pure substances. But then again, there's just a range of these melting and boiling points, which makes that substance an impure one. Okay, here's a second example question related to the pure substance topic, pure and impure substance topic. So in here it says stearic acid has a melting point of 69 degrees Celsius. A student tests a sample of stearic acid and finds that it melts between 60 degrees and 67 degrees. Is the substance pure or impure? Explain your reasoning. Okay, pause this video to answer the question, and once you have the answer, you can play the video again. Okay, so the answer is the substance is impure because the melting point range is lower and broader than the standard melting point of stearic acid. So it's actually mentioned here in the question already. Stearic acid has a melting point of 69, but the sample, it has the range of 60 to 67, which is lower to what we've known of stearic acid's melting point. So therefore, the substance or the sample of substance is impure. Okay, moving on to the next topic, it is about separation techniques. So there are a lot, and bear with me while I go through this one by one. So the first one here is simple distillation. So what does this mean? It separates a liquid and soluble solid from a solution or a pure liquid from a mixture of liquids. An example is when you want to separate water from a solution of salt water. So this is a diagram of how simple distillation would look like. I'll try to explain it step by step of how it goes. So the solution is heated and the pure water evaporates, producing a vapor right here, which rises through the neck of the round bottom flask. And afterwards, the vapor passes through the condenser where it cools and condenses, which turns into the pure liquid that is collected in the beaker right here. And after all the water is evaporated from the solution, only the solid solute will be left behind. And therefore, the process of simple distillation has taken place. Okay, next is about fractional distillation. So what this means is it separates two or more liquids that are miscible with one another. So what does miscible mean? It's forming a homogeneous mixture when added together. So an example of this is you want to separate ethanol and water from a mixture of the two. So how this is going to work is that, as you can see, the setup would be quite similar to simple distillation, but there are differences between the two. So, okay, first the solution is heated to the temperature of the substance with the lowest boiling point. And then the substance will rise and evaporate first, and vapors will pass through a condenser, same thing like the previous simple distillation, so they also have condenser, where they cool and they are going to condense, turning into a liquid that will be collected in the beaker. So all the substance is evaporated and collected and leaving behind the other components of the mixture. So that is the process of fractional distillation. Thirdly, we have filtration. This is a common separation technique and it's usually appearing in exam papers. So what this means, it separates an undissolved solid from a mixture of the solid and a liquid or solution. So the process here is that there's a piece of filter paper in a filter funnel above a beaker in the setup, and a mixture of insoluble solid and liquid is poured into the filter funnel. So there's this mixture already. For example, from the sample here, we want to separate sand from a mixture of sand and water. So there's going to be already a mixture of the sand and water, and it's going to be poured into the filter funnel. And the filter paper will only allow small liquid particles to pass through as filtrate. So from this mixture right here, it's going to only allow those small liquid particles that are going to pass through and become a filtrate. And the solid particles that are too large to pass through the filter paper, they're going to stay behind and they're going to be called as residue. Okay, next we have crystallization. And what this means, it separates a dissolved solid from a solution when the solid is much more soluble in hot solvent than in cold. An example is copper sulfate from a solution of copper 2 sulfate in water. So the process here for crystallization is first, yes, there's heating. So the solution is heated, allowing the solvent to evaporate, leaving a saturated solution behind. And you have to test if the solution is saturated. How to do this is that you dip it a clean, dry, cold glass rod into the solution. And if the solution is saturated, there will be crystals that will form on the glass rod. And the saturated solution is going to be allowed to cool slowly. And then you'll see crystals beginning to grow. So the crystals are collected by filtering the solution. They are washed with cold distilled water to remove impurities and are then allowed to dry. So in here in crystallization, there's also filtering the solution, which uses the filtration method. So you're going to filter it first. Then you're going to wash it with cold distilled water, and this is just to remove the impurities inside those solutions. And it's going to be allowed to dry, and then you'll see the crystals already forming. And then we have paper chromatography, which will be the last separation technique discussed. This is quite different because there's also a calculation for this one. So I'm going to discuss about that as well. So paper chromatography, what it is. Okay, I'll try to visualize this for you as simple as possible. So imagine you have a box of colorful markers and you want to find out what colors are used to make a black marker. So how are you going to do that? Well, you're going to use paper chromatography, which is a special way that you're going to separate those colors which are included inside the black marker. So as this visualization that I've just mentioned, the definition is that it separates substances that have different solubilities in a given solvent. An example is the different colored inks that have been mixed to make black ink, as previously from the visualization that I've mentioned, and you can do that through chromatography. So there's a picture right here that I've taken from from RSC Education, and as you can see, this is how a paper chromatography would look like. So I'm going to try to take you through it step by step because this is actually a common separation technique as well. It's probably going to appear on chemistry exam papers. So first of all, imagine you have a piece of paper, and as you can see, there is this, and we call this as the stationary phase. And then you're going to use a pencil line to draw on the chromatography paper, and spots of the sample are placed on it. So from this picture right here, you can see there are colors of green, blue, purple, as well as a reddish orange. And those are going to be the sample colors that are going to be conducted to separate these colors through chromatography. So why is pencil used for this? As ink would run into the chromatographem along with the samples, and the paper is then lowered into the solvent container. As you can see, it's going to be lowered into here. And this pencil line right here that you've just drawn, it must sit above the level of the solvent so the samples don't wash into the solvent container. And then the solvent travels up the paper through a process called capillary action, which takes some of the colored substances with it. So as you can see, they've traveled and they keep traveling from this picture right here. And after a while, you'll see the separation of the sample to different colors. So like from this picture, it turns out the green, there has been a separation to blue and yellow. So that shows how chromatography works and how it separates the sample colors to different colors. So there's a note right here. Different substances have different solubilities, so will travel at different rates. As you can see, there are different distances. For instance, the ones with the dark blue, it has a higher distance traveled, whereas maybe the others would be less. And simple way to explain this is that some colors are quote unquote stickier and like to stay on the paper so they don't move very far. So other colors are more attracted to the water and they travel further up the paper. And those substances with higher solubility will travel further than the others. So that means that this dark blue color sample right here, they have a higher solubility and they will travel further than the other sample colors. Okay, now we'll be moving on to the calculations for paper chromatography. And this is going to be using RF value. So what is an RF? It stands for retardation factor, which means it is to identify the components of the mixture. And here I've also already added the formula to calculate the RF value, which is distance moved by substance over distance moved by solvent. So calculating the RF value allows chemists usually, or just as well as us as students, to identify the unknown substances because it can be compared with the RF values of known substances under the same conditions. So do take note that the RF value is a ratio and it has no unit. So you don't have to put any sort of unit for the answer later on. And a tip for me, if I could say, to help you calculate, is that when you calculate R values in exams, make sure you use a ruler and use it carefully to measure the distance moved by the solvent. So in this picture, there's actually already the distance or the label itself here from the diagram, but in reality later on, you might need to have to calculate it using a ruler to measure the distance. So make sure you do that carefully because it could be a strict mark scheme and you would need to carefully calculate it. And of course, for both measurements, the distance should be measured from the baseline to the center of the dot. Okay, this one is quite easy one because we already have the distance. So I'll try to help you calculate and give you an idea of how we're going to calculate it. So we're going to start off with, okay, let's try with the color blue. Okay, so the RF for this is that it's going to be, as usual, distance moved by substance. So what is the distance? From here, you can see it says 8 centimeters. So you can write 8 and distance moved by the solvent, which is actually here, which is the solvent front. We know that this is 10 centimeters. And this is a ratio, so you don't need to have any value. You can calculate this, and the answer is going to be 0.8. Okay. Okay, let's try now with another one, which is purple. Okay, we'll calculate the R value now. And as you can see, the R value for purple is here. This is already quite covered. So it's going to be 6/10, and the answer would be 0.6. So this is just a general idea of how you're going to calculate the RF value. Thank you everyone for tuning in for today's chemistry video. Next, we'll be having another topic about medium, so please stay tuned for that and Learn It by Pintar's YouTube channel. Give a like and as well as subscribe to this YouTube channel to stay tuned for more updates. There will be also other subjects besides chemistry, so you can stay tuned for those as well. See you in the next video.